All right, welcome back to your Algebra 1 exam review packet. I'm going to go to the problem set 15, absolute value inequalities. All right, remember absolute value refers to the distance the number is from 0 on the number line. So we're told that this distance, whatever p divided by 8 is, whatever p is, we divide it by 8, and that number, that resulting quotient, its distance from 0 on the number line needs to be something that's greater than or equal to 3. So it's further than 3 spaces from 0 on the number line. So it's either out here someplace, bigger than 3, or it's someplace down here less than negative 3. So what we do is we break this absolute value inequality into two separate inequalities. So p over 8 is going to work out to something less than or equal to negative 3, or p divided by 8 is going to be something greater than or equal to 3. So either it's something bigger than 3, which means that its distance from 0 on the number line is greater than 3, or it's something less than negative 3, in which case its distance from 0 on the number line is again bigger than 3. And then we just solve these two inequalities separately. So let's take a look here. There's a pen. Oh no, it isn't. It's over here. Okay. We're going to just multiply by 8 times 8 times 8 times 8. And we end up with p less than or equal to negative 24, or p greater than or equal to 24. So we mark, let's see, here's 20, there's 25, so 24 is somewhere around here, negative 24, there's 20, there's 25, so negative 24 is somewhere down here. These are both or equal to inequalities, so we fill them both in, and either we're up here or we're down here. Either p is less than negative 24 or p is greater than positive 24. Let's look at another one that's a little bit different. Down here, we've got a minus 9 as, first of all, look at this. A minus 9, whatever it is, it has a distance from 0 on the number line that's less than negative 14. Well, that would mean like it'd have to be negative 15 or negative 16 or negative 17, but nothing can have a distance from 0 on the number line that's less than, a negative number. So this one has no solution. Okay. Let's take a look at a different one. There we go. Goodness sakes. This is the same way. How can anything have a distance from 0 on the number line that's less than a negative number? No solution. Man, who wrote these problems? Just looking for one that's different. Let's flip the page over here. Okay, here we go. N over 2, absolute value of n over 2 is less than 1. So here, this means that whatever n over 2 is, its distance from 0 on the number line is something that's less than 1. So it's either a number that's between 0 and 1, right? Or it's between 0 and negative 1. So it's somewhere between negative 1 and positive 1. So that means that this turns out to be that negative 1 is less than n over 2 is less than 1. As long as n over 2 stays within this range, its distance from 0 on the number line will always be less than 1. And then we're just going to have to go times 2 on all of these. So negative 1 times 2 is negative 2. N and 2. So n itself has to be between negative 2 and positive 2. And since these are both less thans but not or equals to or equal to, we just circle them. And that means that n has to be somewhere in this region. So notice when we turn these, we're basically turning these into compound inequalities. If it's less than, it becomes an and inequality. On the other hand, if it's a greater than, like right here, greater than, then it turns out to be an OR inequality. Okay? So it's something you want to remember. Put that down in your notes. All right, a couple examples here. I see a couple more where we're going to end up with no solution. That's just freaking crazy. So good luck. Check your answers. Show your work. If you have questions or it's not working out, talk to me. I'm more than happy to help.